In this problem, Lennon wants to enclose his yard with 200 feet of fence where one side adjoins his house. Assuming the enclosure is rectangular, we want to determine the length in terms of the width. So we'll just say the house is on this side, and we'll label the length L and the width W. And since two sides of length W need fencing, but only one side of length L, we can write a perimeter formula as L plus 2W equals 200 since he has 200 feet of fence. But we also want to solve this equation for L since it says determine the length in terms of the width. So subtract 2W from each side and we get L equals 200 minus 2W. And in part B, we want to write an area function A in terms of the width W. And recall the area of a rectangle is given by the length times the width. And substitute the expression we found for the length for L. And we find that A equals 200 minus 2W times W. And if you recognize that this quadratic is in factored form, you could quickly find the horizontal intercepts of this area function. And we should find that there's one W-intercept at 0. And using the area function formula, we can find these other function values. So A of 20, for instance, is 200 minus 2 times 20 times 20. Or 160 times 20, so 3,200. Continuing down, we see that the area function first increases, and then after W equals 50, it starts to decrease. So really the vertex of this function is at 50, 5,000. And so we can use that point to graph the function and use another point in the table to obtain the graph of this parabola. Lennon hopes to enclose at least 4,200 square feet. What is the smallest width that will create this area, and then what is the greatest width? Looking at our graph a little bit more closely, locating where the area is equal to 4,200, and that occurs when the width is 30 feet or 70 feet.